Welcome to this tutorial on the 4-channel oscilloscope integrated into the NILAB Starter software. Let's begin by configuring the motor movement between two positions. As you can see in the table, the displacement is set between 10 and 50 mm, with an acceleration time of 200 milliseconds and a dwell time of 150 milliseconds. Before moving to the graphical analysis, let's start the cycle. Turn the motor pressing ON button and initiate the sequence by pressing Start Motion. Now, let's switch to the oscilloscope window. Typically, the standard configuration uses channel 1 for position feedback and channel 2 for the target position, while channels 3 and 4 are dedicated to feedback velocity and target velocity, respectively. The interface is divided into several functional sections. In the channel section, each signal can be individually configured and enabled via its checkbox. The Auto Scale button allows us to scale the signals based on their amplitude for optimal visualization. In the center, we find the trigger configuration, which can be set to various signals. Here, we can adjust the sampling time from 250 microseconds up to 20 milliseconds to capture shorter or longer intervals. On the right side, you will find the measurement cursors. Let's proceed with the acquisition by setting a cycle time of, for example, 1.3 seconds. By clicking Start Acquisition, data is collected in real time within the motor's memory and then transmitted to the software once the process is complete. Given the communication speed of 115.2 kbps, we'll wait for the transfer to finish before manipulating the data. Once the acquisition is complete, the signals are displayed in different colors, as shown in the legend at the top right. To analyze the signals more closely, we can activate the double oscilloscope mode to split the channels into two separate graphs. In this mode, you can perform specific zooms. Right-click to select the zoom function, then click and drag with the left mouse button to enlarge the area of interest. To return to the original view, simply use the Zoom Out command. Now, let's look at using the cursors for measurements. Returning to the single graph mode, select the Select function, and click on your first and second points of interest. The software will automatically display the values and the time difference between them. In this case, the measured distance is approximately 350 milliseconds, which perfectly reflects the settings entered in the motion controller. 200 milliseconds of movement plus the 150 millisecond dwell time. Once your analysis is finished, you can save the numerical data by clicking Save to File. This creates a .dat file organized in columns. Finally, the oscilloscope offers a real-time mode to monitor the variables from the status bar on the left. After enabling this function and starting the acquisition, the signals will stream live on the screen. To improve visibility, simply increase the zoom value of the individual variables, typically to 500 or 1000, to clearly see the real-time signal trends.